Welcome to the Course One podcast. In this podcast, we explore the emerging open financial system. We dive into scalability, interoperability, proof-of-stake, blockchains, and many other parts of this coming financial singularity. Tune in every Monday to dive deep into these cutting-edge projects and protocols with Course One team members and guests.
Hi, welcome to the Course podcast. This is Brandon from Course. And today I have Christopher Goes from the Cosmos Tendermint Inc., right? Is it all in bits? Is it
all of the above? All of the above.
Okay.
Thanks for having me. My name is Christopher. I work as a researcher and the project lead on IBC for Tendermint Cosmos, and also as a co-founder of the validator company Cryptium Labs.
Yeah, so let's jump in there, right? So, I mean, how does that work at the moment? I mean, you're contracted through Cryptium Labs to work for All in Bits? Is that how it works?
No, I have an employment agreement with All in Bits, and I also on the side work on, but I'm not employed by the validator.
Okay, great. Yeah, so I think what would be interesting is just to kind of get a sense of your background, right? I mean, you've got a really interesting background across a lot of different projects, so I think it'd be worthwhile to kind of track your journey to crypto. So from what I can understand, you started with like autonomous underwater vehicles. Is that right?
It goes back a little further. So
okay.
I actually learned about, and perhaps I am embellishing these memories in retrospect, take them with a grain of salt. I don't have written documentation, but as best I recall, I first learned about Bitcoin in high school. And I learned about it because I wanted to rent a virtual private server. I must have been 15 or something, I believe, to host a website. I taught myself how to use Apache Dreamweaver, that will date me, to write, which was a WYSIWYG editor for HTML and CSS. And I wrote a little personal website for myself, long since gone from the interwebs. But I wanted to deploy that on a virtual private server. But since I was 15, and wasn't up for stealing my parents, I didn't have a credit card, so I couldn't rent a server. And I sort of did some searching, and somehow, I think through Slashdot, came across Bitcoin. This must have been in 2011. And so tried to mine some Bitcoin so I could use it to rent a virtual private server, which I did. This was back when it was GPU mineable, and I thought that was pretty cool. But beyond doing a little bit of GPU mining and at one point spending some time on the Bitcoin Talk forums, I didn't do that much at that time. I thought Bitcoin was an interesting experiment, but I was skeptical due to its technical design and due to certain choices like the fixed supply curve, of its ability to end up fulfilling the original statement in the white paper of a peer-to-peer digital cash. And I think that skepticism was warranted, but I probably should have paid more attention to some of the other projects going on in this space, like what became Ethereum at that time, more programmable contracting systems, etc. So for most of college, I didn't do anything with cryptocurrency at all. I mostly studied computer science and physics and worked on a underwater robotics team, which built autonomous submersible robots that competed each year in a competition in Southern California.
So talk a little bit about that. I mean, how autonomous are these? Is it similar to like the work that was going on, or at the same time with autonomous vehicles? Right? Are you doing kind of LiDAR, or how do you navigate underwater?
So each year we built from scratch a submersible robot, probably about 35 kilograms, and that's as big as a large suitcase, and then shipped that robot down to a former, actually still current, but somewhat retired, Navy acoustic testing facility in San Diego, California, called TransTech. We put the submersible robot in the water, disconnected it from our tether, so we disconnected it from the computer, pressed go, and then for 20 minutes it had to navigate around this giant pool. I think it was 200 meters in diameter, navigating an underwater obstacle course, picking up objects, sorting objects by color, going around PVC pipe constructions of particular shapes in particular acrobatic maneuvering patterns, etc. And then according to its performance, which was all autonomous, so the submersible navigated using cameras, vision algorithms, LiDAR, radar, not so much LiDAR because it doesn't work underwater, and you can't surface or you lose points. So mostly radar and vision, and occasionally touch sensors, which are quite dumb but useful in their simplicity. Through those sensory mechanisms, the submersible was able to navigate around this obstacle course, and then based on how well it did sorting objects, maneuvering, it would be scored, and we competed against teams from all around the world.
Okay. And how well did you do?
We did pretty well. I think one of my years came in third, another year, I don't recall all the placements. It was lots of fun. I learned through discussions with people in industry who we met on various field trips that our autonomous submersible was more advanced than anyone actually used in industry. Most of the industrial demand was for undersea mapping, mostly by the military and by private firms, oil drillers, etc. And those submersibles just basically executed a search pattern, didn't do anything interesting.
Yeah, cool.
Understandably, in industrial settings, you need 5 nines of reliability, and our autonomous vision algorithms did not have 5 nines of reliability.
Sure. And I guess they didn't have to deal with fish and like plastics and things that you might find in a real like nautical environment, right?
Right. Well, even in the simulated environment of the pool, they did not have 5 nines of reliability. If it was a particularly sunny day, all of the vision algorithms would miscategorize sunspots in the water as buoys or something. But
sure. So am I right in sensing that, because you went on to found Stash.ai, right? Was that straight out of college? Did you just decide, like, was it always clear to you that you wanted to be an entrepreneur and do your own thing?
It's a good question. I just tried a lot of things, and entrepreneurship seemed like a good thing to try. Yeah, I would say it was pretty intentional. Stash was and is, in fact, it's still running, a automatic bookmark classification service. Yeah. So Stash gives you a button in your browser that you can click to stash a link, just like you might bookmark a link. But when you stash a link, it's categorized by a machine learning algorithm as some kind of content, a book, a song, a movie, an article. So it's an attempt to structure unstructured data on the web. And it works pretty well. But we elected, after launching, we sort of had the option of using users' data and basically selling advertising or selling your data to make money, or charging users. And we didn't really like the idea of selling users' data. Bookmarks seem pretty private. That seems a bit disingenuous. So we elected to charge users, which works fine, but it means that it's not necessarily a massive scale product.
Okay. Cool. But it's still up there and running.
Yeah, it's still running.
That's great. And so then it seems like you got into Wyvern Protocol. So how did you get back to crypto then? So 2011 you discovered Bitcoin, and at some point you came back and said, yeah, okay, I'm going to build a DEX for NFTs on top of Ethereum, right? How did that happen?
Right. I decided soon after college, when I was looking for something to do after Stash, that I really wanted to get back into the decentralized ledger space. And I did a lot of things. It wasn't just Wyvern. I also worked on this was about when Tezos was launching, I worked on a compiler from Haskell to Michelson, which has since metastasized into another project that Cryptium Labs is now working on called Juvix, a dependently typed contract language. At that point, it was not so advanced, but the name stuck. And I also decided to teach myself Solidity. And to teach myself Solidity, I thought I would build a centralized exchange protocol. This was probably a terrible idea. I ended up learning a lot of Solidity, but it was torturous. But I ended up with a nice decentralized exchange protocol. So it was effective in achieving another goal. Wyvern's not specifically an NFT protocol. Rather, it is an asset agnostic exchange protocol. So consider something like a simple decentralized exchange on Ethereum, like EtherDelta. EtherDelta was very popular when I wrote this. When you use Ether Delta, you sign a particular order struct. So when you want to place an order on the exchange, you sign over the denomination of tokens you want to send, the denomination you want to receive, the price, and like the maximum amount or something like that. In Wyvern, you don't do that. In Wyvern, instead, you sign over a validation function. So you sign a function that gets executed on the transaction which the order matches. So you sign a validation function over your call data and your counterparty's call data. And all that function has to do is return a Boolean. So you can basically sign an arbitrary order. You could say that you'll exchange a blue-eyed CryptoKitty for a red-eyed CryptoKitty, or you could say that you want to purchase these 5 NFTs for 2 Ether and 6 DAI. Any expressible transaction on Ethereum is just some byte sequence call data, and you can create a predicate function over that call data to compute anything computable within the gas limit, at least. So that's the idea. My hope is that in the future, although mostly it's used for NFTs and some other cool use cases on OpenSea, my hope too is that in the future it will be used for a complex multi-party contracting. Like, for example, I tend to use this example of shoe manufacturers. So let's say there are a consortium of shoe manufacturers who are all manufacturing sneakers. And these manufacturers want to reduce the carbon impacts of their supply chain. But if any one of them individually, unilaterally chooses to do this, if they trade off any sort of efficiency for reduced carbon outputs, they will end up with more expensive sneakers. And this means that consumers will buy their competitors' sneakers instead, and more carbon conscious sneaker manufacturers will go out of business. In fact, they won't have succeeded in reducing the carbon emissions of the industry as a whole. So what you need to solve this problem is some atomic commitment ability. You need all of these sneaker manufacturers to agree together to all incorporate somehow this externality cost of carbon outputs into their supply chain at once. And if they agree atomically, then the price of downstream sneakers will go up a little bit, but as long as no one can defect, they will actually have succeeded in doing this. And I think that in that kind of threshold commitment, there are sort of 2 problems. And both of them blockchains can actually help with. One problem is the problem of contracting. Right now, it's expensive in terms of legal transaction costs just to construct this kind of contract between sneaker manufacturers, and it's hard to enforce. But the second problem is just one of discovery. There's not a way to write a kind of open-ended legal contract such that if any other sneaker manufacturers also write such a contract, once all of them do, it will automatically execute. But you can do this with a kind of decentralized exchange order. Once you write an order for trading a red-eyed CryptoKitty for a blue-eyed CryptoKitty, if anyone else happens to have a blue-eyed CryptoKitty, they can match your order. And the discovery mechanism for you two to find each other can be, automated pretty easily because it's all computable data. Does that make sense?
I think it does. The only gap there is, how do you verify? There's this idea of, okay, you have a commitment on the chain, but how do you get, where's the oracle that says, I can import information that says that you actually delivered on your commitment?
Right. The oracle is the hard problem. Blockchains don't solve the oracle problem, but they may provide some useful substrate as part of a solution. In particular, I think what blockchains can help with is serving as a payment settlement layer for certain kinds of mechanisms. So mechanisms where certain parties are responsible for reporting information and other parties could challenge that information. And you could construct sort of shelling commitment games, or at minimum, at least notarize the data on the blockchain. And the other thing they can help with is separating Oracle access to data from particular applications. So it's pretty easy to say there's some Oracle, and it can even be a company. I don't think blockchains and crypto economic mechanisms are going to replace necessarily institutions serving a lot of these functions. But if there's some institution which does analysis of carbon outputs of supply chains, that institution can publish its data maybe once to some blockchain, or at least publish notarizations of the data, and then other blockchains can verify that, maybe with the help of IBC, pretty cheaply. So you don't need a separate oracle for each particular set of contracts between companies which have supply chains, something like that.
Sure. Makes sense. Yeah. So, I mean, what's interesting there when we kind of look into your background is you seem to be drawn to just really difficult problems, right? Like the underwater vehicles and, building various different AI technology and complex DEXs and compilers. Is that what brought you to crypto? Is it the challenge of solving these difficult problems that drives you, or is there some kind of bigger vision, that's maybe political or some kind of social vision you have for where this could take us?
That's certainly part of it, but I think probably the primary motivation is a perhaps naive, we shall see, but a perhaps naive idealism that decentralized technologies will enable more ethical and reliable large-scale software systems. I am personally of the opinion that a lot of the large-scale software systems, especially the platforms which have been built by platform companies such as Facebook and Google and Microsoft in the past few decades, have ended up not due to malicious design, at least not initially, but just due to the structure of how incentives have worked out and the structure of attention competition, in particular in a free market, have ended up not being very long-term incentive compatible with their users. What do I mean by that? I mean that I think many technologies which are sold to consumers are nowhere near close to in the best interests of those consumers in the long term, in terms of consuming their attention, in terms of not providing accurate information, in terms of exploiting information asymmetries between large companies which have very sophisticated machine learning advertising targeting capabilities and individual consumers who don't really understand where data is going, and in terms of simple reliability. I don't think we've succeeded in building air traffic control systems, financial systems, technological systems anywhere near close to the level of reliability they need to have for the things for which we already use them. Certainly nowhere near close to the level of reliability they need to have for future use cases like networked autonomous vehicles. Right now, I think networked autonomous vehicles are just a mistake. Look at the reliability of our software. You want to give control of what is effectively a high-speed tank to code written in Python and JavaScript. It strikes me as terrifying. So I want to work to improve the state of things in all of those respects.
Okay. I mean, and that seems to kind of align with the work then on Juvix, right? Where you're looking to kind of formally verify software. Is that's a big part of your vision for how this needs to work? Is that correct?
That's right. Now, a brief caveat. I am becoming less and less of a fan of the term formally verified software because every time I hear it used, it means something slightly different. I'm always a fan of verifying software, but in particular, what Juvix has is what's called a dependently typed type system. Dependently typed means that terms written in the language can express properties of other terms in the language. So you can write without, and some kinds of form verification, you have sort of a spec, and then you can use some tool along with that spec to check properties of an implementation of the spec. But the spec and the implementation are separate, so there's a lot of room in between for making mistakes. You could end up verifying the spec and having a correct spec, but the spec in fact mismatches the implementation, and it turns out you haven't verified the thing which you're actually running. So it's possibly, yes, less useful. The idea behind dependently typed languages, which Juvix is nowhere near the first of, much more common ones now are Idris, Agda, and Koch. The idea behind dependently typed languages is to allow you to verify properties of terms in terms themselves. You don't have this awkward bridge layer between spec and implementation. However, existing languages like Idris, Agda, and Koch are written primarily as theorem provers. They're not written to produce efficiently executable code. For contracts where compute and storage are quite expensive, this is a game breaker. You really need efficiently executable code. So Juvix tries to combine the essential power of these dependent type theories, which have been in the academic literature for a while, with some more recent research into something called quantitative type theory, and some nice sort of like whole program optimization passes to produce efficiently executable smart contracts that can be verified in this formal manner. I would definitely class it as a research project still, but it's making rapid progress. You can find all the code on GitHub.
Do you ever see this as accessible? Like what kind of I always wrestle with here is it feels like it's going to be very hard to write these, whatever we call it, but say let's just call it formally verified contracts. Will it be accessible like to the average developer, or do you always think that like for something like say autonomous vehicles or financial smart contracts that you just have to have advanced developers writing these things?
That's a good question. I'm not sure I know what the answer is. Are smart contracts like websites? Will everyone be writing smart contracts? Or are they more like database systems? Will only kind of a small subset of people end up writing them? Maybe it's somewhere in between. I would say though that I think the difficulty of working in like functional languages is a bit overblown. I mean, Juvix, once complete, will be similar to Haskell, say, to write. And it will be possible to do a sort of progressive verification. So you could write a contract that's just like in a functional style, like writing Haskell or writing OCaml or even writing functional JavaScript, and then verify it later or ask someone else to verify it or create a bounty on a blockchain for proofs of properties of your contract. So it's possible to separate the tasks of authorship and verification, which certainly makes sense when you just want to quickly prototype something and test it, but might also make sense if different people have different skill sets. My other hope is that it will be possible to split the tasks of proof checking and using software. So to back up a step, what would be the ideal case is if everyone in the world who uses smart contracts can themselves check the proofs that these contracts behave as anticipated. Whenever you interact with an ERC20 contract, for example, you ought to check that it actually behaves like an ERC20 contract, that when you send funds, they'll go to the person you sent them to. When the tokens are fungible, that they all can be exchanged for one another. Right now, this doesn't happen at all. When you interact with an ERC20 contract through MetaMask or through whatever, it's following a particular interface for encoding the call data, but that contract could really be doing anything. There's no guarantee that when you call transfer, it will actually transfer. There's no guarantee that what you're transferring behaves like a token. When most of the people writing smart contracts are nice, that may work okay, but it doesn't scale. It certainly doesn't scale to large-scale software systems, and it doesn't scale to cases when there are Byzantine actors involved. And I think we should really be designing for cases where there are Byzantine actors involved. Okay. However, it's also not feasible to have everyone write proof check themselves. But what might be feasible is to have intermediary software that is not authored by the contract authors, but that is used by the users, do this kind of proof checking. So think like wallets. When you use a wallet to interact with a contract, it could have some knowledge of what the behavior of an ERC20 spec contract is supposed to be, and it could display a green check or red X, depending on whether or not that contract had provided a proof that it fulfilled this behavior. So I think that sort of system is possible.
Yeah, that makes sense. Cool. Okay, let's jump to IBC. So, I don't think this is the right place to go into the details of what, the technical implementations of IBC. So it's, for those who don't know, it's the Inter-Blockchain Communication Protocol. It allows chains to basically communicate with each other. Yeah, I think what I'd like to focus on here is just like, assuming we have this protocol standardized, where do you see the value, right? Like, is it really needed? Like, what's the value proposition for having this internet of blockchains? What's the competitive approaches, right? What if we didn't have IBC? What could you do with some kind of cross-chain wallet and SPV proofs? And then you've got, I guess, potentially competing technologies like tBTC, where you can move assets across chains in a very different way to IBC, right? Where you generate these kind of private keys through secure multi-party computation. So I guess there's a lot to unpack there, but yeah, I guess like what is the value for IBC with IBC?
My hope is that IBC will help enable a sort of polycentric network of blockchains. By polycentric, I mean that different blockchains will have the ability to specialize in different tasks, that there will be a lot of fluidity, that it will be easy to spin up new blockchains, spin down old blockchains, modify existing blockchains. Sort of the topology of this network can change really rapidly without any kind of central coordination. And in order to handle that kind of dynamic topology, you need a inter-blockchain communication protocol that is built for it. IBC is built for it. And this differentiates IBC from, to my knowledge, pretty much everything else out there in terms of interchain protocols. I don't think IBC and tBTC are competitors. I think they are more like things you would use together. So tBTC solves a very specific problem of creating a pegged, in some sense, ERC20 token on the Ethereum chain, which is pegged to the Bitcoin asset, so the logical like Bitcoin. When you have these tBTC tokens on Ethereum, you'll be able to send them around as ERC20s, use them in contracts, but then also redeem them back to Bitcoin should you desire to do so. And I think it is a great approach to solving that problem. IBC does not solve that specific problem. IBC instead solves the much more general problem of arbitrary payload interchain communication. So say you have a contract on Ethereum, which you want to talk to a module on Cosmos, or a contract on Solana, which you want to talk to a WASM contract on Near Protocol. IBC provides the transport, authentication, and ordering layers needed to get packets, which can contain anything, from these contracts or modules to one another. So it's kind of like cross-chain contract calls on Ethereum, where you can just send any data you want, and the semantics of that data are up to the contracts involved, except that it works across blockchains. In particular, it works very well between chains which have fast finality and relatively inexpensive in terms of compute and bandwidth, like client verification algorithms. So IBC is complementary to things like tBTC and to specific bridge designs, which are really, like tBTC is very, very well designed for the case of a Nakamoto consensus chain talking to Ethereum. And you might well use that to create an ERC20 asset on Ethereum and then send the ERC20 over IBC to the Cosmos hub, and then you could use it there. So I think there's a lot of positive some interaction between these interoperability protocols.
Okay, yeah, makes sense. So like, what would you like to see in terms of these chains? Like the various chains that pop up. Like, I guess first, the first issue that I have like with this like internet of blockchains vision is just how do you see all these chains being secured, right? There still seems to be a kind of bootstrapping issue here. If somebody launches a new chain, how do they secure that chain? Particularly if they're use cases around custodying assets or somehow, transferring assets across chains. Security seems to be a huge issue here. Is that correct?
Yeah, I think it is, but I think it's one that can be mostly automated in time in fashion such that users who have some way to authenticate an existing chain would be able to verify once a new chain is spun up that it has some prerequisite level of security for their use case. We haven't worked on it yet, but it will be possible to build on top of IBC an application layer protocol for some cross-chain validation in a sense, a way for new chains which spin up to automatically, given the consent of the validators, automatically pay for validators that have an existing chain like the Cosmos Hub to start validating their chain and to put some assets up at stake, which could be slashed if they commit an equivocation, so that the new chain will rapidly get whatever amount of security they're willing to pay for as soon as they spin up and interact with this protocol through IBC. Mm-hmm. So I think that, and it will be possible for, let's say, if I'm a user and I have some assets custody in the Cosmos Hub, and I see, there's this new chain, is it safe for me to move my assets there? I can check, did some of the validators, which were previously on the Cosmos Hub, start staking on this new chain if they put up enough at stake, etc.
Okay. Sure, but that's starting to increasingly look like a prerequisite for this multi-chain world, right? Particularly with Cosmos Zones. Do you not think that there's an urgency now to actually get that solution in place?
I think that there's an urgency, yeah. if anyone wants to start working on it, all specs are public. I will not stop you. I would vote for a grant from the Cosmos Hub community pool. Maybe AIB will get to this sometime next year. I can't commit to anything in particular. We're focusing on the core IBC protocol first. But
sure.
Yeah, I think this absolutely is a priority.
Yeah, I mean, I think the challenge from our point of view in Chorus, we've certainly looked into it like in some detail. It's just there's so many possible ways of implementing this shared security model that I think there'll be some interesting debates of just trying to figure out what is the best way of implementing it. So.
Right. I guess my approach would probably be to take, like IBC takes, a sort of primitive first approach. So to first create primitives for renting security, for like attesting that a validator has moved to a new chain, for slashing across chains such that collateral can be kept in one location and used to collateralize multiple chains. And then on top of those primitives, start thinking about marketplaces or automatic settlement engines to kind of clear the demand and supply curves of chains wanting security and validators willing to provide it, et cetera. So I'm not sure what the topology will look like in the end, but it seems like experimenting is a good way to figure out.
Yep. Sure. And then what about, so like talking about like people building applications on top of IBC, I guess we've got the first application coming through, right? Is that correct? With Everett are building this Interchain account feature. Do you want to talk about that, or have you got visibility of any other kind of people that are looking at building applications on top of IBC, the application protocols on top of IBC?
Sure. So to provide a little bit of context, application layer protocols on IBC specify semantics for particular kinds of packets and how they ought to be handled. So they are a pretty direct analog to, you could say, ERC specifications on Ethereum. So ERC20 defines some ways to call into a token contract and defines what those calls are kind of supposed to do in terms of transferring tokens. And there's also an application layer IBC protocol. We actually called it ICS20, which I am still not sure how I feel about, but whatever. ICS20 facilitates token transfer across chains by specifying particular packet encodings and semantics for how those packets ought to be handled. Then Everett has started work on an interchain account specification, which will allow delegation of control of an account on one chain to an account on another chain. So you could sign with your key on the Cosmos Hub to send transactions on Ethereum, say, if you use this protocol. That is already in a pull request on the ICS repository on GitHub. Other things I'm interested in. I am really interested in somebody, and I don't care who it is, creating a multi-asset shielded pool, which can be interfaced with over IBC, such that all assets which could be sent over IBC could then be shielded. And by shielded pool, I mean like the thing what Zcash has, but in addition to shielding the amount sender and recipient, also shielding the asset type, so that you could have all of these, ERC20 tokens maybe, and Atoms and Ether and Zcash, whatever, share this same anonymity set over IBC. I think that would be super beneficial. I don't know quite what Zcash's plans are. I know they've made some noise about multi-asset supports that could work out, and maybe it will end up being a Tendermint zone. Who knows? That's something I'm particularly interested in.
Okay, cool. And then where are we now? Because you guys have been making a big push recently for the hackathon in San Francisco, right, to get IBC ready for that. And then Game of Zones seems to be imminent, right, or at least maybe Q1. That should be happening. So can you talk about where's the state of IBC now? What needs to be put in place before we're ready to kick off Game of Zones? And then maybe just talk about like what the goals are for Game of Zones, like, and what challenges you face trying to get everything ready for that.
Yeah, so we had I would call it a early prototype implementation of IBC, but early prototype implementation of what will be the 1.0 spec at San Francisco Blockchain Week about a week ago. And that was used by a few teams in the DeFi hackathon to build. One team worked on a system for pegging to Bitcoin. One team worked on, I believe, an IBC bridge between two substrate chains. IBC, I'll mention it, is not Tendermint specific. Tendermint works well with it. The Cosmos SDK works well with it, but you could also use IBC between other consensus algorithms, between other blockchains. It's a sort of implementation agnostic protocol as long as the consensus algorithm and state machine fulfill some basic requirements. Now, on the AIB side, we're working on finalizing the spec, on having some auditors take a look at it, make sure we haven't missed anything, on finishing up the Tendermint Lite client, and hopefully formal analysis of its security model. The Interchain Foundation has been doing some fantastic work in TLA+, in particular looking at bisection, which is a technique we use in Tendermint to skip headers, and making sure that that's secure. And hopefully we'll have that all ready for quote-unquote launch of IBC sometime in the next few months, although I can't commit to specific deadlines.
Okay.
Game of Zones is a follow-up to the Game of Stakes incentivized testnet, which we had before the launch of the Cosmos Hub. And it's in that spirit, but extended to IBC. So there will be multiple blockchains involved and different challenges related to sending packets, creating applications, trying to DOS the system or find bugs, etc. Hopefully that will probably be operational sometime in early Q1.
Okay, cool. And how long do you see that running for?
It depends. If we've done our job really well, maybe no one will find any problems at all, and it will only take a few weeks. If people find interesting bugs, we might extend it. We plan to keep it a bit shorter and more structured in phases than Game of Stakes was. We've learned some lessons from that first go-round. So hopefully it'll be pretty smooth.
Okay, cool. So, I guess final question, what's your hopes for the Cosmos ecosystem? You're obviously putting a lot of personal effort into IBC and making this all work. What do you see are the risks or the threats? What's the worst case outcome here, and what can we do to mitigate it, right? And maybe then just talk about your vision. You've talked about multi-asset shielded pools, right? But what else would you like to see here? What do you think needs to be delivered before you would be able to call Cosmos ecosystem a success?
I'm not sure if there's a particular state and time I would ever consider a success. My personal view is that blockchains are not necessarily long-running entities. I think there's sort of a confusion between blockchains and assets in this respect. Blockchains are infrastructural substrate. They're kind of like servers. And servers have become much more impermanent over time. You now spin them up when you need them, get rid of them when you don't need them. They're mostly virtualized. Subject to some constraints about managing security correctly. I think blockchains will end up infrastructure-wise playing a similar role, and being able to upgrade them really rapidly, I think, will be key for allowing decentralized infrastructure to compete with centralized infrastructure. Right now, it can't. There's just no way that blockchains can innovate rapidly enough to provide services to the really broad-based consumer market. And I think in order to be able to compete with Google and Facebook and these platform companies, we need to be able to upgrade our infrastructure really rapidly. And I hope IBC will help achieve that. So in some sense, success looks like the Cosmos network, probably invisibly to the end user, but serving as the infrastructural substrate for decentralized platforms that compete with the centralized platforms that provide financial services, social services, data notarization services, etc., to 6 billion people, and can innovate rapidly enough at the infrastructure layer to make that possible.
And in that context, how important do you see? At the moment, we're still in a world where you've got crypto exchanges that are, instead of their power being diminished, they seem to be increasing, right? Do you see that as a threat? And how do you see that playing out? Or you think that's something that can be ignored? That if you just focus on building the layer that allows people to build decentralized services, that will happen over time. That there will always be centralized services, and therefore you can just ignore them, right? But the people that want to build decentralized services and the people that want to use them will find their own way in the world. Or do you think we can, do you think we can safely ignore the threat, or do you think there has to be some kind of proactive steps to mitigate the risks here?
I think in the long term, in the long term, the markets will be efficient. So decentralized technologies, if they really are more resilient and provide better incentive alignment to the end users and can build up brands over time of resiliency and of incentive alignment, I think they will be able to outcompete centralized services. If that wasn't true, then maybe they didn't succeed in providing those properties in the first place.
Sure.
However, in the short term, it's absolutely, I suspect, the case that you can cut corners, build a centralized exchange, give out some security properties, and provide a better user experience. I don't think this is bad. I think centralized exchanges onboard a lot of people to the ecosystem and get them into the, dip their feet into the decentralized technologies, maybe in fashions which they wouldn't otherwise have if there wasn't that kind of gateway available. In the short term, the thing I'm mostly concerned about is how centralized exchanges interact with proof of stake, particularly with respect to over-securitization and derivative creation. I think there are some existential threats to proof of stake if we end up with too many secondary markets, and I'm not really sure how that will play out. We kind of just have to wait and see. But I also don't think there's a good way to stop it from happening. So probably best to just create a really resilient set of many, many different proof of stake blockchains so that it's hard for a failure of a single one to cause too much damage globally.
Sure. Yeah, look, there's a whole heap of issues there. We certainly need to come back to that. I mean, I think the financialization or over-financialization of crypto is certainly a risk, and it's certainly one that's on something we're investigating, obviously, because we're somewhat involved in that space. Unfortunately, I guess we're out of time, so we'll leave it there. Thank you so much for your time, Chris. It was really great to talk to you. Really interesting kind of discussion. So thank you very much.
Thank you.
Thank you for listening to the Chorus One podcast. Visit chorus.one for more information about our work. Don't forget to subscribe to the podcast to stay tuned on new episodes airing every Monday.